Welcome back, Year 10 Physics, Double Science, Lesson 5. We're going to be learning about ring main circuits and use of standard form as well as SI multipliers. Let's look to see where that fits in on the syllabus first of all. Okay, so these are the highlighted parts of the learning objectives of the syllabus, different lessons, coloured in different colours as we've seen before. So what we're doing today really is just going in a bit more depth on something we covered in lesson 2, where we looked at parallel circuits. So in purple, as you can see here for lesson 5, it says to pupils to learn an appreciation of types of household circuits, for example ring main circuits, household lighting circuits, and can be linked to topic 1.4, domestic electricity. That's something you're going to be learning later in year 10. And the second learning objective I've written in there separately, use of standard form and SI multipliers. SI standard for standard international multipliers. Standard form is something you have probably covered in maths, or certainly will be covering as part of your GCSE course. Standard international multipliers, it's this idea here where you've got, I'll just highlight that, you can convert from one number to another. Not particularly useful there for 750 watts perhaps, but when you've got very large or very small numbers, it becomes very useful. And these standard international multipliers can be found, the conversion can be found in the front of this booklet and also the exam papers. So let's just go back to the booklet. Make sure obviously you've written in lesson 5 and the date. And your first task here is to describe what ring main circuits are. It asks at the top, you may well think that electric sockets are connected in parallel as in the diagram. So that's this diagram underneath. Let's just label a few of the different parts. This is the fuse box. Just there. And the sockets, of which there are multiple, are here. So these are electrical sockets, and of course that's what we use to plug in appliances. So there's your fuse box. You'd find that in one part of the house, perhaps in a garage or by the stairs in your house, and these sockets, of course, you'd find them in multiple different places all around the house. So we're looking at how the electricity comes into the house and then is supplied all the way around these different sockets. Now, to help you answer that, underneath there's some notes to the right hand side here. I've taken this off the revision guide for this course. I want you to include in your write-up the advantages of a ring main circuit, and you can see them there. There's a diagram underneath to help you gain a better understanding. And notice here as well, that's the symbol for a fuse, and you'll notice a fuse is always in the live wire. Now you're going to use this diagram here to do the second task, which is at the bottom of the page, and you can see there are 3 wires shown in 3 different colours going around the circuit. There's black, red and green. And if we zoom in on one socket, you can see a bit more detail where these different wires go. Now the green wire is earth. Right, so we've got an earth wire, the black wire is neutral. And the final and third wire is the live wire. The live wire is the dangerous wire. It's the one that's got the 230 volts flowing through it. And with that, you have the electricity. So there's neutral, there's earth, and there's live. And with that, you have the switch and fuse is connected in with the live wires. So if you were to trace one of those wires all the way around the circuit, let's choose a different color for highlight then. Go down to I'll do it in a grey color. If we trace, say, the live wire all the way around, like the live wire can go that way, and then go these different sockets. But also it can go that way. You can go different sockets on the way all the way around. And if we trace it back here, that will take us then to the fuse box that we saw a picture of on the left hand side, and you can see it's got these circuit breakers in the fuse box and many other things. So I'll just get rid of that highlight then. So that's the way your ring main circuit works. Notice for the earth wire, you'll see this symbol just there. Connection to the ground and the sheath of the cable which brings the supply into the house. That's as much as I'm going to say about ring main circuit. I've given you a quick overview there. There's some points up above to help you with that. So that's your first task. The second task is to complete this diagram here, and complete it by drawing in the earth wire. And again, you can look at that diagram that I've just shown you by rewinding the video and see where the earth wire goes. I'll make a quick start, and I'll use a green pen. So remember, the earth wire, it goes to the top pin in the plug. I will show it with a green colour. The actual colour of an earth wire is yellow and green. So I want you to draw that all the way around. I'm not going to complete it for you. I'm going to just put in some different sections of it. So that will be the earth wire. And just as they have in the diagram we just looked at, it's good to show how the earth wire is actually earthed, and we use this symbol again. I'll do it here. Okay, so that's for you to complete. Now that takes us on to the second learning objective, and that's using powers and the importance of powers of 10. And that'll take us on to SI multipliers and standard form. First thing I want you to do is write down what this means to you. When I say this means to you, I'm talking about this number here. So that large 10 and the small 2. You'd have met it before. Pause the tape, or the video, sorry. Pause the video, and in the box below, write down what it means to you. Okay, many of you would have written down perhaps 10 squared. You might have written down 10 times 10. You might have written down 10 to the power of 2. And on the right hand side, I'd like you to do the same thing just underneath in the booklet. Pause the video. Okay, you might have written down here 10 cubed. You might have written down 10 times 10 times 10. You might have written down 10 to the power of 3. Even 1,000. This will be 100. There's lots of ways of writing that down or describing what it means to you. Now, we're going to not just be dealing with 10 to the 2, we could be dealing with numbers much larger, 10 to the 7, to 8, 9, 10, or 10 to the minus 7, and many others. Okay, I'd like you to just read through what's on the screen at the moment and pause the video. Okay, I'm going to do one large, one small, and leave the other two for you to complete. If we firstly look at the number 410,000, and we need to change that in the standard form, I'm just going to follow the instructions shown here. And first of all, it says convert the number into a value above 1 but below 10. I'll do this on the right hand side. So we need to convert that in the standard form. And I always think the standard form, you have a number, a decimal point, a number, and then it's times 10 to something. So I got that in my mind. So I'm thinking 4.10 and it's times 10 to something. Now that 10 to something is explained here. With large numbers, start at the decimal point and work out the power of 10 moving left to the last number. So what that means is the decimal point here in this large number, 410,000, would be just there. And to go to 4.1, you have to go 1, 2, 3, 4, 5. So all you do is put in 10 to the 5. Now let's think what that means. What is 10 to the 5? It's 10 times 10 times 10 times 10 times 10. You could write that down as 1 with 5 zeros after it. That's what 10 to the 5 means, because 10 to the 1 is 10, 10 to the 2 is 10 times 10, which is 100. You get the idea. 1,000. 10 to the 4 is 10,000. Therefore, 10 to the 5 is 100,000. So you multiply that 100,000 by 4.1. So 4.1 times 100,000 takes you to 410,000. The answer then is here, 4.1 times 10 to the 5. Write that in the box. I'm going to do now this a small. So you do the, and I'll put a red asterisk next to it. You do this one, and you're going to do that one there as well. I'm going to do this one here. 0.0005. Write this here. 0.00005. Let me just check I've got the right number of zeros. Yeah, 4 zeros after the decimal point. Now this time you go the other way. You're going to write it down as, sorry, you're going to write down the standard form as 5.00 times 10 to the something. So all you've got to do is work out what that something is that goes here. So let's do that. 1, 2, 3, 4, 5. And it's, because we've gone to the right and not to the left, it's minus 5. 5 times 10 to the minus 5. You complete for the other two. Underneath, there's some questions for you to do. If we look at question 1, it says write the numbers below in powers of 10. If we look at this first one, 1, 2, 3, 4, I'd write that down then as 6.00 times 10 to the 4. And I'll choose one at the end here as well. So it'll be 2.3 times 10. 1, 2, 3, 4, 5. Minus 5. You then do the remaining questions. These here. If you're not sure, just rewind the video. Okay, quick explanation, and then underneath why we use standard form, because in short, we don't want to be writing those huge numbers down in physics or science. It would take forever. So what we do, in this case for example, we know it's going to be 6.0 times 10 to the something. Let's work out what that something is. 3, 6, 9, 10, 12, 15, 18, 21. Apologies, miscounted there. Just paused and redid that. I'll have to learn my 3 times tables again. So we go in 3, 6, 9, 12, 15, 18, 21, 24. So we write that down as 6.0 times 10 to the 24. And remember the units, in this case, kilograms. And that's really why we use standard form, is because it's far quicker to write the number in that way than that way. And also, can you imagine the amount of space it would take in your booklets? If we go the other way, dealing with something that is really small, the mass of a hydrogen atom, then if we do the same thing, look to see where the decimal point is here, and we've got to take that to 1.67, so it's going to be 1.67 times 10 to the something. So we're going to go 3, 6, 9, 12, 15, 18, 21 happens to be 24. And this is in grams. I'll put a video in this lesson in Moodle to give you a better idea of the importance of powers of 10. Some other examples of very big and very small numbers. The speed of light waves is often written as, now I think of it as 3 times 10 to the 8. That's how I remember it. I wouldn't remember it as this, which would be 300 million meters per second. This method of number writing is known as standard form. So if we look at this, write 2 million as a decimal number. What do I mean by decimal is this. 6 zeros is a million. In standard form, we multiply 2 by 6 zeros. I'll do a couple more underneath and then pause the video and you complete the rest. So 15,000 is standard form. I break it down like this. 10 to the something. 1, 2, 3, 4. You do the second part of question 2. Question 3, 9.2 times 10 to the 8. So what you're doing here is going the other way. You're going from standard form to decimal, or ordinary numbers as is in the booklet. So I've got to, now this decimal point's got to go 8 times to the right. 3, 4, 5, 6, 7, 8. Now let's just check that. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that all seems fine. And again, you do the second one. Question 4. We're only moving the decimal point one place. So that's 5.5 times 10 to the minus 1. Again, you now do the remaining 3. Now there's another way of writing down numbers, and it's using these SI multipliers, or SI stands for Standard International, meaning that the same code is used all around the world. So every scientist and engineer, mathematician knows, for example, what lowercase m means. It means something totally different to uppercase m. Lowercase m, the prefix is milli, and it means we multiply by 10 to the minus 3, where mega means you multiply by 10 to the 6. Underneath that table then it says you could write down 5 kilograms in 3 ways. Let's look how we can do that. If you think of kilograms, I'll write it over here, 5 kilograms. The kilo is a different colour. The kilo, this bit here, is the symbol. We call it kilo, the prefix, and it means 10 to the 3. It means multiplying by 1,000, effectively. So to write it down using the prefix, we use k, the prefix. The powers of 10 would be 5 times 10 to the 3, and the units would be grams, or in decimal, 5,000 grams. Those three are exactly the same value. I'll do question 1 with you, because we're dealing with smaller numbers. Now this time, if we look at the prefix, we've got to firstly see how many times, 1, 2, 3, we need to move the decimal point. So if we move it 3 times, then it's going to be 10 to the minus 3, and that's lowercase m, milli. So we can write this down as 3.8 milligrams. Powers of 10 would be 3.8 times 10 to the minus 3, because we're making that 3.8 1,000 times smaller. The unit is grams, and decimal, it's already in the decimal form above. Now I'd like you to go ahead and complete the remaining questions for this lesson. Well, with this question here with the chocolate bar, it's asking you how much energy it contains. If you can't see on your booklet, that is the amount of energy there, 995 kilo, that's a prefix, joules. Question 4. And go on and complete the rest of the page, down to the bottom of page 29. Remember to look at the video which accompanies this lesson and to complete the plenary assessment that goes alongside it. See you next time. Bye.